This is a 2000 Volvo S70 all-wheel drive with a loping idle. It's kind of hunting a little bit. So let's give you a listen for just a second here. All right, while I set up my auto tap, any numbskull is pretty much going to put an idle air control valve in this thing under the guise of, it's idling funny. There is something called an idle air control valve. That must be the problem. I love the logic. But one of the problems I'm anticipating having is I know for a fact, first of all, I've only seen one Volvo ever before in my life, and it didn't work with my scan tool. And that's kind of getting to be the situation here. What I really would like to see is idle air control valve movement. Wow, there's not even a O2 sensor 1. Now this is going to be useless. This is going to be a real problem. Let's go ahead and just pull up some stuff. Let's see how our fuel trim's doing here. See if maybe this is a result of some fuel shortage. They did say that this happened after getting a fuel pump and nobody's been able to figure it out. They had actually got a second fuel pump installed, and that's not the problem. Let's get some long-term here. Only three things could really do this. You would have adjustment of the injector pulse width, adjustment with the idle air control, or adjustment with the timing that I can think of. I'd like to see what the computer is trying to do in order to make this effect here. Let's go ahead and pull these up because this is all I've got. And let's zoom in for you here. All right, right off, I'm seeing something interesting here. Gosh, so we can see our loping idle right up here. Probably be easier to graph that. Let's put some of these in a graph. All right, so I've graphed a couple parameters here that I thought might be the most useful out of what I've got. And what we've got in red up here is our loping engine speed. And I've only got my downstream oxygen sensor. This is not upstream. It looks like an upstream, but what it's doing is it's going lean every time the engine lopes. So almost like a fuel shortage. And indeed that is what they thought, because this problem, they say, was congruent with a fuel pump problem. Of course, if they were having fuel pump problems, they might have had this problem before and not known it. What I am paying attention to, because I'm very limited in my data that I can get here, I have nothing that I really want. What I'm interested in is right here. Look at this throttle position angle at 18%, and it actually changes. Now, I'm not familiar with the mechanism on this system, if this is one of those systems that has the motorized throttle position where it's kind of a combination of the IAC and the throttle position. But this 18% average seems very, very high to me, and I would say that that's probably going to be the first place we're going to look. All right, real quick before I go ahead and look at that throttle body, at why that throttle position sensor value seems high, I wanted to, because this may be a quicker and less exciting video than I was hoping that it would be, I wanted to talk about why I'm going in that direction, and I so snottily dismissed the idle air control or some other things. So the first thing, idle air control, I'm well aware that if you go to any chat room and you describe this problem, they're going to tell you you got to replace your idle air control because they don't understand what's happening here. I do believe that loping, hunting idle is the result of the idle air control moving, and not that that's the cause of the problem. What I really wanted to do was get scan tool data to look at some IAC position and desired position and things like that to show that the computer is effectively controlling the IAC, and basically that would mean that there is some other problem. I was assuming maybe a vacuum leak where the idle air control is trying to be compensated by the computer for whatever this other problem is. So put simply, that loping and hunting is not the problem. It is the result of the problem. It is the computer basically trying to compensate for it. Only one way that can happen, and that would be a functioning idle air control motor. So replacing the idle air control motor would not fix this problem. It would still do the same thing. The very fact that it's loping and idling, to me, indicates the idle air control is working. The other thing is I wanted to check fuel pressure, particularly because that's a reasonable thing given the fact that apparently this problem happened after a fuel pump was changed. Unfortunately, I don't have the right adapter for this fuel system with my fuel pressure kit, so we're not going to be able to go on that. However, I'm dismissing fuel pressure, and there's a couple reasons. I would have loved to dismiss it with an actual pressure measurement and with scan tool data. I don't have scan tool data to be able to help with the fuel pressure analysis because I can't get an O2 sensor 1 reading. But what I can tell you is this. The loping only happens at idle, and the engine runs perfectly fine with no hesitation, no stumbling or anything under normal driving and even wide open throttle. There's no evidence whatsoever of a fuel delivery issue, at least as far as just by feel. I would have loved to do it by some more quantitative means. But that's why I've dismissed the IAC. That's why I'm dismissing fuel pressure. And again, that 20% throttle position on the scan tool with the engine idling is definitely a red flag for me. So that's why we're going the direction we're going, in case you were wondering. All right, I was able to hook up a fuel pressure gauge, and as expected, this is not a fuel problem. What I'm looking for is to see that there's a drop in fuel pressure with the loping, and there is not. The fuel pressure is holding plenty steady, so fuel pressure is eliminated. This is not a fuel delivery issue causing this problem. All right, I guess that makes for a good video, I suppose, but that was just a matter of it's easier to try to rig up something to check the fuel pressure than it is to get to this throttle body. So, you know, the point with my videos is to show the diagnosis. My philosophy is if you really need a video to show you a part with bolts attached to it and removing the bolts to take out the part, then, you know, maybe I'm just a little bit judgmental, but I just don't see why you need that. I can, you know, you can look, you can see what's in the way, and you remove it by removing the bolts. I don't need to make a video of that, I'm hoping. But what I do want to do is I'm going to go ahead and tear this down, and we'll get a look at that throttle body and see if we can find some type of explanation that is concordant not only with those symptoms, but also with a 20% throttle position. Again, that's really the only useful data I can get on the scan tool. But we'll have to see what happens when we get in there, so I'll be back. And just for you that are curious, if you're trying to do this on your own vehicle, I found that removing the fan is probably the best way to go here. And what we're looking for is this guy right here. And not quite sure how to remove him yet. I can see that this air intake hose does go right up to the underneath of that device there. That clearly is some type of electronic throttle control. Maybe I should research it. And looks like there might be some bolts underneath it. So, but anyway, the point is removing the fan seems to be the best way to get access to this very difficult area on the car. All right, I just want to make a special note to any automotive engineers out there. Just because you do something different does not necessitate that it is better, okay? I do not understand why things have to be like this. I hope I never see another Volvo as long as I live. Not that I'm opposed to new things, but if there's a new way, I'll be the first in line, but it better work this time. And with my fan removed and with the air intake duct removed, we can see right here, see if we can look between these pipes here, there is my throttle opening right there. And it's kind of hard to see what condition it's in as far as carbon buildup or whatever that might be causing this problem. But I've got nothing else to go on. I've came this far, and what we're going to do is go ahead and remove this thing. It looks like we've got maybe 1, 2, 3, 4 bolts that are holding this thing on. So I'm actually underneath the car looking up at this thing, which is actually on the very bottom of the intake manifold. I just don't understand why this is of any benefit to anybody whatsoever, but I'm going to go ahead and pull this thing out of here and let's see what we find. All right, I've got our prise pulled out a little bit. I'm underneath the car where I've pulled this thing from. Again, I don't do bolt by bolts very much. The idea is with the diagnosis here. And my figuring is that if you need to see a video with how to remove bolts to remove a part, then you're probably not interested in the diagnosis anyway. And I don't want to be part of the propagation of more parts changers. But anyway, what we've got here is, let's see if we can get a good shot here. But this throttle is actually open quite a bit. There's a pretty good gap there. I don't know if you can see it. And there's quite a bit of carbon buildup around the lip. And it looks to me like this may be, let's see if we can position this light here. All right, maybe that's a little better, but it does look like it might be preventing this thing from closing all the way. This is a fully closed position here. You can see there's definitely quite a bit of opening there. So I think we may be on to something here. So let me go ahead and remove this thing from the car and we'll take a closer look at it. All right, here's our prize. We can see, probably you can see from this angle here, you can see right through that throttle plate. It does seem to be open quite a bit. So what I'm going to try to do is clean up a bunch of this carbon and see if that'll help to maybe get it into a little more realistic position. You can see we've clearly got motorized idle air control and built-in throttle position sensor on this unit here. Hopefully I don't have to replace this whole unit. I'd imagine that'd be pretty expensive, but let's see what we can do with it. All right, here is our nice cleaned up throttle body. Almost looks brand new. Even put on a new wiring protector for those bare wires. So what I'm going to do is go ahead and hook up my scan tool, and we'll see if we can read the position of this thing when I plug it back in. All right, so with it plugged in, it does still read 20, but I'm thinking that's okay because that might be a learned position. I'm going to try to open and close the throttle, and we can see that it does open, and you can't actually close it to 0. So what I may try to do here, I'm not sure if this will work. I don't want to run the car too long without the throttle body and the turbo hooked up and everything, but just maybe start the car real quick and see if it tries to close the throttle body. And if this throttle position sensor here goes down, then I'm actually going to be pretty happy about that and think that maybe we have a potential fix because it can adjust. So let's just try that real quick and see what happens. All right, we got a little backfire there, but I can see that it did actually go to 0. And indeed, the throttle is completely closed. That actually may be a good sign. So that means that it can actually adjust a little bit below 20%, which is what I probably would like it to do. Maybe I'll go ahead and reinstall this thing, and we'll see what it looks like after I reinstall it and run the engine, and if we have any difference with the throttle position and, of course, with that loping idle. All right, I've run the engine a while to let it warm up, and check this out. Throttle position now adjusted to 7%. We'll just take a listen for a while here. You can hear it just idles absolutely perfect. That is amazing. I will admit I wasn't totally convinced that that was going to work so well. I was a little nervous that we might end up having to redo all this work and replacing a part, but that is awesome right there. So I am happy. I am going to call this a fix, and we save the customer a ton of money, I'm sure, because I'll bet that that electronic throttle control module would have been rather pricey. So I hope you found this helpful. Thanks for watching.